Welcome, everybody. Before I start with my actual talk, I need to fulfill a little promise. I made a little prostitute of myself because there is Robert, one of the guys from Mayflower, and he's taking photos of me on stage in a church, which I would really love to see on the internet. And in order to get him to that, I promised him to present this little poster. So this is by Mayflower. If you are interested in Symfony, and I guess you are as you are here, go to their booth and get one of these fancy posters for your office. It's free, actually. Okay, that was the Mayflower marketing. Welcome to my talk of Make Your Project Solid. First, a few words about me. My name is Tobias Schlitt, as you have seen on this slide actually already. I have a degree in computer science. I am a passionate professional PHP programmer since 2000. There were many P's in one sentence. I'm also pretty enthusiastic about open source, and I have a passion for software design and automated testing. The passion for software design also incarnates in this talk, Make Your Project Solid. I'm also a co-founder of a company called Krafu, and what we do is we help people to create high-quality web applications. So if you're in need of expert consulting in terms of software design, quality management, testing, continuous integration and all that stuff, or if you need an individual training on these topics, don't hesitate to visit our website. From 2013 on, we also have one of the core guys on board. We got Benjamin Eberlei hired. He's working for us from January on. He's a core contributor to Doctrine 2. So if you need something in that direction and need one of these trainings involving Symfony or Doctrine, don't hesitate to contact me via email or after the presentation. That was the marketing things. So why should we actually take care about stuff like Solid? Solid is all about good object-oriented design. And what we currently have in the PHP world, in all those lots of legacy applications originating back from PHP 3, PHP 4 times, and also in many PHP 5 applications, is something completely different, and that is stupid. So this stupid acronym resulted from discussions on Stack Overflow, basically, where people were told, like, okay, you're doing it wrong, you should do Solid, you should do graphs, you should do other object-oriented design stuff. And with this stupid thing, somebody summarized what is going wrong in most of the PHP projects. And what we have there is, we have singletons, which is static access, tight coupling of code together. We have, these tight coupling things also beside the singletons. We have code that is untestable. Solid helps there quite a lot. And we have premature optimizations, which make spaghetti code, which is blazingly fast, but nobody can maintain it anymore. We have lots of indescriptive naming, where Solid cannot help you if you do stuff like that. And we have code duplication. That is how the world looks like today. Mostly. Hopefully not in your projects. But if you want to do something against that, Solid is a first step in the right direction to get your code in the right way. If you want to learn more about that, I created a bit.ly link for you. So I will upload the slides later on, so you don't have to note down that link, of course. Solid. Why do we do Solid? Because software development is not a Jenga game. Whenever you want to adjust your software to new needs, if you want to fix bug or something like that, you don't want to pull one of the pieces of your software and make it crash instantly, completely. Therefore, we want to do Solid, and what Solid is on the next slide. Solid is an acronym, and it refers to 5 really essential principles of object-oriented design. If you are familiar with object-oriented design patterns, you will obviously realize in each of these patterns that they try to follow the Solid principles. So instead of learning all the patterns and trying to apply them constantly, you should better concentrate on such principles as Solid and get them really into your bones so that you intuitively use them in everyday software development, and it will really create way more better code than without them. Solid was defined by Robert C. Martin, who is also known as Uncle Bob. Maybe some of you have heard about that. He's not the inventor of all of the principles, but he combined them to this full package of Solid and said this is the most essential parts, and I need to agree with them. They are proven to lead to better code in various languages. Among them is PHP, but also in Java, C#, and so on. So you can apply all those principles to any other object-oriented language too. And they have partly scientific background, so that is for the scientists under us. If something has scientific background, it must be great, right? Okay, so I'm not a fan of UML diagrams and things, so I will show you PHP code, but please do not start and copy my PHP code and just adjust it to your needs. That's not the idea. Try to understand the principles behind that, the ideas behind that. If there are any questions in between, don't hesitate to raise your hand or start crying or screaming or get angry or something. Just let me know that there's something wrong. It's pretty light here on stage, so I don't see you properly. So giving some noise would be an optimal solution, I guess. Okay, as an example, I'm using one of our training examples from Quafu, which is originated from a component design which we did in one of our trainings. And to give you a slight background, this is the component requirements which we had later on. So it is around a weather loading component, which should be fetch weather for a certain city, such weather information as conditions, temperature, and wind. The component should be service agnostic, so they first started off at the customer with asking Google for weather information, but there were thoughts like, okay, if Google shuts down the servers or if they start charging money for it, we should switch to a different solution. Also, if Google is down, they wanted to have a failover. If they cannot reach Google, they wanted to ask other providers for weather information, and such service failures should be logged. So just to give you a little bit of context on what the code examples I will be showing are about. Solid. The first of the solid principles is the single responsibility principles. And as the slide here says, just because you can put everything into one object, into one class, does not mean that you should. Who has ever tried with such a Swiss Army knife to cut down a really huge tree knows what I'm talking about, right? So what does the principle say in detail? There should never be more than one reason for a class to change. That is a pretty abstract concept, and I try to fill that with practical knowledge for you. So I hope everybody can still read that. Otherwise, please come a little bit up front. You can also sit on the floor here. It's way better to read. Well, however. In this example, we have a Google Weather Service. This Google Weather Service has one dedicated public method which is meant to be used from the outside. It's getWeather4Location. It receives a location in form of a plain value object, and then it does stuff in order to retrieve the weather and return a weather object struct, right? So it's a pretty small API, a pretty small class with some code in it. Let's investigate that code a little bit more. First, we have in that main method, we retrieve some XML data from somewhere using another method called getData. After that, we take that XML data, put it into an extractWeather method, which is also on the same class, and then we return it. This extractWeather method, again, contains multiple lines of code, which is quite okay, because we are in programming, right? We want to write code. But however, there are lots of calls to protected or private methods here which do lots of stuff. Retrieve the data, which is probably done somehow over the network. Then we have these extractWeather, which does parse conditions, so there's some parsing logic behind that. We have some conversion logic. We need to parse the wind speed and so on. So here are some dots at the bottom of this class indicating that there should be quite many private and protected methods among that. Has anybody an idea what the problems with this code are? Can anybody spot problems here? Is it fine? Is it good code? Anybody? Everybody still awake? Pardon? No comments, yeah. That is just originated to the slide, but yeah, of course, no comments is also a bad thing. XML format changes, yeah, that might be a reason for this class to change. So whenever something in the XML format changes, we need to touch this class, and we potentially put bugs into that class, right? Any other idea what could happen here so that this class changes? The weather class is hard-coded, which might not be a problem if it's a pure value object and does not have logic, yeah, but that could be a problem if it contains logic, so it's not injectable, but that's a different principle.
The wind speed is always in the one.
Pardon?
The wind speed is always in the same metric or unit.
The wind speed must be in the same unit, so if Google decides to change the wind speed to kilometers and not deliver it in miles anymore, then I need to change that class, right? So if Google changes the overall data format, if it changes parts of the data format, if Google decides to to locate the weather service in a different location, I need to change that class. Any more ideas?
Not sure if weather is correctly filled.
Okay, we are not sure that the weather is correctly filled. I assume that happens here right in the dots, but yeah, that is also the weather is filled in. So we already found like 4 concerns when this class could maybe change. Well, we get the requirements in the future that we need to change this class. And what the principle says is that there should only be one reason for a class to change. So what we can do is we pull out responsibilities from this class, because this class obviously does too many things. As we had with the Swiss Army knife is nice, but Swiss Army knife does way too many things in order to use it for a sensible job. And it's the same with this class. So what we can do is we can rip out 2 of the responsibilities into their dedicated classes and put them into whatever own classes to realize their own concerns. For example, I can move out the HTTP client here and the data parser here, and then I have 2 classes which only change if one of their concerns changes. And this class, the Google Weather Service, is only there to put the glue code among these 2 new objects retrieved as dependencies, and it will never ever need to change this class, except for maybe if the URL of the Google Weather Service changes. But that's the only case where I really need to change that. Everything else works completely fine here. Right?
No.
No. Please.
You have XML format coded here. So if Google decides to feed it in like JSON, it's a second reason to change it.
Not really. That is only if I want to rename that data thingy, so I could rename the class to optimize it to data, but I won't need to change the class, because then I just give it another Google data parser which parses JSON. Then still the variable says XML, but yeah, I don't need to touch the code if I don't want to.
Okay. And it's a verbally named variable.
Yeah. Renaming that variable is a pretty good idea for the next instance of the talk. Absolutely. Okay, so the idea is to design classes in a way that they only have one responsibility per class. If you ever heard about separation of concerns, that is exactly the same thing. What you intend to do in order to have modular, flexible, maintainable, and also testable code is to rip your responsibilities, your action that your application does, into as small pieces as possible. Of course, you need to stop somewhere in order to not destroy your business value, but doing stuff like we have seen here, putting lots and lots and lots of stuff into one class, is not the solution. Try to think about what is the responsibility of something, what is it intended to do, and then rip out all other pieces which are not common for that single class. Like in that case, retrieving data, parsing the data, and creating the weather class together is not a good thing. Putting that out into different concerns, into different classes, is the way to go. After that, you can instantly solve most of the problems that could affect this piece of code by injecting new implementations of these interfaces we defined. Of course, responsibilities are pretty hard to detect, but you're a software developer, so you have quite some experience. You have lots of colleagues at home. Get in your team, ask them, discuss with them, do you think this is way too much code, and learn from them. That is an important thing which you should always do in terms of object-oriented design. The second principle of the solid principles is the so-called open-close principle. The idea is, if you want to just put on a code, it's no need to have open chest surgery for that. Nobody wants that. So the real principle says software entities, classes, modules, functions should be open for extension but closed for modification. Damn. Now I killed myself, I think. Almost. Okay, what does it tell us? Let's look at an example again. We have again our weather loader, and this time the weather loader receives some service in its constructor. And inside the getWeatherForLocation method, we have a big switch which asks, okay, if I got the Google Weather Service, then I need to react like that, because I retrieve it from a library. If I got a weather.com weather service, then it's completely different, because it has a different API. So I know how to deal with that, and I know how to call that. There's a big problem in that code. because everybody looking at that code and getting the task to extend it with a new weather service will instantly do what? Of course, append a new case below here, because you need a new case in order to provide it with a new API. But that can potentially instantly break your class. There's so many things that can go wrong in that situation. For example, he can forget to do return. He can forget to do a break. He can accidentally remove whatever, a semicolon somewhere. There's so many ways how somebody can destroy that class with appending code to it. If you have tests for that class, you would also need to touch all of the tests. So in order, when you touch all of the tests, there is a high risk that you destroy your tests and that your tests do not check anymore what you initially intended them to do. So touching test code and needing to touch test code is not a really good solution. So the idea should be that instead of dispatching to these weather services in that dedicated APIs using a big switch, instead of that, you introduce your own interface, which is called a weather service, and after that, you only need to pay attention to that interface. And behind that interface, you can hide all of the complexity which the dedicated weather services have. So, if you want to extend this mechanism here, like to work with different weather services, the only thing you need to do is to look into your weather service interface and implement that interface against a new provider API. You don't need to touch existing code. You create a completely new class which you can test dedicatedly, and you don't need to touch existing code and possibly destroy it, have the risk to destroy that code. So the idea behind the open-close principle is that changes always introduce errors, or have a high probability to introduce errors. That is especially true if you have cascading changes, like if you touch the essential classes of your project and introduce an error there, then there's a high probability that your complete application dies. And that is the worst thing which can happen to us as application developers, that our application is just dysfunctional. Not parts of the application don't work anymore, but the full application. And that can happen if you touch existing, tested, or proven to be correct code. Even if you don't have automated tests, if you have code which is in production for half a year, then you can be pretty sure that you messed out all of the bugs that you originally put into it. If you now start changing that code, you again come into risk that this part of code breaks. So the intention is that you ideally write code once and extend your application by only implementing new instances, new interface implementations, new inherited classes, or by aggregating existing classes. That is the ideal world where you want to drive through. That might not be the possibility for you to achieve soon, but it's the idea where you want to walk straight on. There's also the Liskov substitution principle, and that is, from my experience as a trainer, one of the things that is most done incorrect in especially the PHP world. So what does it say? It says functions that use pointers or references to base classes must be able to use objects of derived classes without knowing it. Let's look into an example. That's a really, really small class. It's really, really nice because it consists of so few lines of code, and it's so easy to test and so nicely to use. It's a distance converter. It only has one method, and that converts miles to kilometers. We give it a mile value, and then it returns us a kilometer value. Obviously, also, I did not display the documentation to you. You will see this is a float, and what it returns is also a float, right? So we have in our project, we have a very, very smart developer, and that smart developer thinks, oh damn, that distance converter is nice, but in every case where we use it, actually, we basically need the return value as a formatted string. Every time we use the distance converter, it is only displayed on our website. So why should we always do the same thing, format the return value of the distance converter and display it there? Let's derive from the distance converter and fix that issue. Right? We don't want to touch the code, so we extend the class, the existing one. And what the extension does, it first adds some error checks to it. So if it retrieves a negative distance, that is complete bullshit. There exists no negative distance, so we throw an invalid argument exception. And we fix the stuff we originally wanted to fix. It does not return a float anymore. Instead, it formats the float nicely using the system locale, so it's already in the customer's language formatting, and return a nice string. What's the problem here? Pardon? It should return float, actually. Everybody who uses a distance converter expects this method to return a float. So if somebody actually wants to calculate with the returned value, and now you inject the formatting distance converter, you're doomed. All of your calculations might break. If I install that on a German server, then I will have a comma in here, and then PHP will instantly cast everything from there to 1. Nice, cool thing. Another problem?
Should not throw an exception.
It also should not throw an exception, exactly, because everybody expects from the original implementation of that method that he can throw any type of float into it. And if it's negative, then it should return a negative calculated float value. So nobody takes care about this exception because nobody knows about it. The basic interface of distance converter does not provide any information about that an exception could be thrown. So nobody takes care about that exception, and in the worst case, you get a nice stack trace on your website if you just inject the formatting distance converter instead of the distance converter. So what that boils down to is, if you extend an existing class or implement an interface, in both cases, you must stick to the contract that is provided. You may not change the input value to be more strict, and you may not return other values than you are expected to. So I usually explain that in that way. You have this miles to kilometers method, and you have some input value, some output value, and you have a range what that is that might be in. It is not okay to restrict that input range, because you cannot make sure that nobody in your project uses these parts of the input range that is not accepted by your method anymore. On the same thing, you may not widen the output range, because you cannot make sure that nobody in your project relies on the original output range. Normally, all using code will do that. What you may instead do is the other opposite around. It is not the problem that your miles to kilometers function in the derived class can use strings. Nobody takes care about that. It will never receive strings, actually, because nobody will use it that way, except for it has a dependency on the derived class. But it doesn't hurt. So if it can cope with strings, that's fine. The other thing is, if you will only return floats greater than 0, everything is fine. Everything works. But it may not throw the exception, because the exception is another thing which is output. It is some kind of output which nobody accepts from it. It's not the return value, but it's still output from your method. Okay, any questions so far? Nobody. Is everybody still awake? Yeah, please.
Also the reason why you may not change a, say, public method to a protected one in the subclass, because
Absolutely.
you use the subclass in place of the base class.
Absolutely. The remark is that is also the reason why you may not change a public method to protected. Exactly, because everybody who has a reference or expects a reference on the base class must be capable of using the subclasses as the base class transparently without ever knowing it. PHP also warns you about some of these cases. Like, for example, if you have a type hint and want to change the type hint in a derived class, you get an error where people are mostly complaining on the PHP internals mailing list, like, well, PHP gives me a weird error, I cannot replace the type hint with something else, but it's exactly that. Never do that. And so many people do it, like, oh, I cannot solve it the other way. If you are in the need of doing something like this or this, do yourself a favor and think how you can refactor that stuff in order to make it better, because otherwise chances are really high that you break your complete project with just one inheritance. Okay. So the essence of the Liskov substitution principle is that you should not change the contracts of your base classes by inheriting from them and changing how the method reacts. Of course, you should change how the implementation looks like, what the details of the implementation are, maybe how the service with which your classes communicate or whatever thing, but do not change the behavior that is expected to the outside. Very, 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 very important. No code user, no using code must distinguish if it has a subclass or the original class among that. If it has the interface or if it has an implementation of the interface. Very, very, very important thing. Another term for this Liskov substitution principle is subtype polymorphism. Anybody ever heard of subtype polymorphism? Maybe you raise your hand if I can see it. Oh, not really. So if you think about classes in the PHP world as types as we know them from C or something similar, like a new type definition, then if you receive a value of a certain type, you expect that type to fulfill everything that the base type has. Like if you have a struct, then you expect that all variables in that struct still exist in an extended struct. And it's pretty much the same with subclasses. A subclass might change how something is calculated internally, how some communication takes place, how some internal details change. But it may not be that some expectation that you have on the master type does not apply to the subtype. So subtype polymorphism, using subtypes exactly the same as the base type, must not change. And that is pretty much the same as this Liskov principle. Okay. Next principle, and that is the second most important thing. If you buy a lamp in an electronics store, you expect that it has some plug which you can plug into the wall and then the lamp works. So nobody would think about fetching that stuff to hardwire a lamp into the wall. However, in software development, it's often the case that stuff is hardwired into classes. Let's look at an example. No, first look at the principle itself. The principle consists of two parts. The first part says high-level modules should not depend on low-level modules. Both should depend on abstractions. And the second is abstractions should never depend on details of their implementations, but instead details should depend upon the abstraction which they want to realize. Let's look into some code again, because that sounds really abstract again. We have the weather loader again. This time it receives a Google weather service and a file logger. What it does with them is, I don't care about the Google weather service, but I care about the logger this time. So it does some logging, pretty obvious, pretty straightforward. And at the end of the method, it tells the logger write to file. Anybody seen a problem here? I'm sorry, a little louder, please. How does it know what to write? The logger? Oh, that is part of the logger actually, but the problem is something different. Where to write? It's also defined in the constructor maybe of the logger?
Formats.
The format? Not really. But why the hell would I tell a logger that it should write to a file? What happens if I want to replace that with a database logger? Or with a gray log logger, or with a logger which keeps stuff in memory instead of logging it to a file. Is it then still necessary to call this write to file method? It's the logger's responsibility to write to the file and when to write. I don't care. I, as a user of the logger, I don't care how the fucking logger does it. I even don't care if it's a file logger or not. So putting a dependency on a file logger and a Google weather service is simply not the idea. I rely on details in that case. As a weather loader, I don't care if my depending class, my weather service, asks Google. It can also ask Yahoo. I don't care if the logger puts stuff into a file. I don't care, it can put it anywhere. I don't want to care about it. That is the idea of object-oriented programming, that I, as a user of some class, don't care about the details. Otherwise, I won't need object-oriented programming at all, because it does not hide complexity in that case. I need to know details on the implementation, how the logger does stuff. It writes it to a file, and it needs to flush it some cases. But I don't bloody care about that. So the idea should be, of course, that I put a weather service here. I define a nice interface for a weather service which does not give me any details on if Google is asked to retrieve the weather, or if the weather lies hard-coded on my disk or is fetched from a database. The same applies for the logger. I only want a logger to receive log methods. I don't care when it's written. And if it's written on destruction, then it should write it on destruction. But it should take care on its own. I want to create an abstraction in that case in order to hide what actually happens in the background. And that is one of the most dangerous things which you have in software development. If somebody asks you to write a logger, it is instant for a programmer that you see the code in your mind, right? You have that, oh, a logger, yeah, that is something that writes to a file. I need to open the file, I need to write the message to the file, I need to close the file. But that's the wrong idea. The idea is to ask, what do I, as a user of a class, desire to do with it? What is the desired interface, and not what is the realization behind that? And that is meant by the principle. You have a high-level module here, which is the weather loader, which is a very specific component already in your application, and it relies on low-level components. A logger. A logger is a very low-level architectural component. It's an infrastructure component, which you, for example, pick from Symfony or whatever, pick it from somewhere. So you don't want to rely on the details of that implementation which you're using. And the other way around, the details, how a logger is implemented, should not influence your abstraction way. It should be hidden behind your abstraction. Then you gain the goal of object-oriented programming, reducing complexity and encapsulating complexity into classes. So you should use abstractions in order to encapsulate low-level modules, and that is one of the most often occurring tasks which we do in everyday development, creating abstractions, encapsulating stuff so that it's easier to use. Otherwise we could just write spaghetti code, because we do everything on our own anyway. So we do object-oriented programming in order to hide the complexity we have behind a facade, behind something that we can easily use and which makes it comfortable for us and secure for us to use. And if you do stuff that I've shown on the slides before, then you completely destroy that idea. You have your APIs. Abstractions define your APIs of your modules, of your components. All of the nice and nifty Symfony components have a nice API which allow you to replace the mechanisms behind them with different implementations. So this is only possible since somebody made a sort up on how to write that API, how to create that abstraction so that people can easily use it, no matter what is behind that. Again, summarized, abstractions need to hide the implementations, need to hide the complexity. You should depend on interfaces and never on realizations. Never have in mind, oh, I already know how this will be implemented. Think about how you want to use something, how to want to use an abstract concept, and not how somebody else will ever implement that. If you do that, you cannot easily switch the implementation. With a logger, we will have a write-to-file method which does later maybe nothing. But we may also have something which, whatever, is disturbed by the write-to-file method. We don't know today. We just have the requirement that we want to log something. And in future it might change, whatever, 10 times that our customer tells us, oh, I want to log to whatever other service now. So think about an abstraction, make an abstract API for it, and then you can replace the implementations in the backend. Always define interfaces from a usage point of view. Never think about something like, oh, I already realized that, so I'm extracting an interface here. That is not the idea how interfaces are used. And also, dependency injection. Everybody heard of that? I want all fingers to be raised now. Everybody heard of dependency injection? Yeah. Dependency injection only works on basis of that. There is no sense in injecting dependencies if you rely your abstractions on details. Dependency injection only makes sense if you can transparently replace your currently configured object with other objects. That's the only purpose behind dependency injection. And if you want to do that, you need to obey to two principles, and that is dependency inversion and Liskov substitution. Otherwise, you cannot do it. Also, if we jump back a little, if we have this write-to-file method below here, and we want to implement a new logger for a database, we would instantly need to violate that Liskov substitution principle. Because what we expect from that public method write to file is that in that case everything is actually written. So if that method concluded, we are sure that stuff is written. So write to file, if we have a database and we want to encapsulate every insert statement into a transaction, then stuff is already written way before that. So we cannot really ensure that this write-to-file method does what it wants. The same applies for a Greylog server, for example. Of course you can hack around that, like, oh yeah, I keep stuff in memory and I do whatever thing, but in the end, that is only hacking around it. It's not really nice, clean coding. Questions so far? please.
This is called substitution principle. What about arguments?
What kind of arguments?
Method arguments. In subclasses, are there any specific restrictions to apply that?
So the question is if there are restrictions which apply to arguments in subclasses, in method arguments. Basically that is what I explained 10 slides ago, that method arguments may not change in the way that they are restricted in subclasses, they may only get broader.
I was referring to adding
adding additional parameters. Now I got your question. Okay, so the question is if adding additional parameters violates Lichkov. Basically, if they are optional, no. If you make optional parameters in subclasses, Lichkov is not violated because everybody who is using a reference to the base class, they will just get the default parameter. But adding mandatory parameters to methods, of course, violates Lichkov. So this is not a solution to the problem to add a mandatory parameter. I think PHP even warns you.
Yes.
Yeah. Does that answer your question? Okay. Okay. So the last principle I want to go about, I think you already missed the I, but I think the I is not that important as the other principles are. It's the interface segregation principle. Maybe you have tried to give your computer to your mother and then ask her to plug the mouse into it. Everybody has ever tried that? Or in former times, ask the mother to dock the monitor cable into it, or father or grandfather or whoever is not really keen on computers. Did you ever try that? I mean, the computer does not care where to plug in the USB cable, but normally old people think like, what the fuck, where should I plug it in? Is it the top left or is it the blue one? I don't care, just plug it in. Yeah, but can I make something destroyed here in that thing when I plug it into the wrong place? No, just bloody plug it in. And it's pretty much the same here. If you see that interface and the USB cable, you have no clue at the first glance where to plug it in. And that's actually a bad thing. So, what does it mean in the matter of software, in the matter of object-oriented design? Users of software pieces of classes should not be forced to depend upon interface parts which they actually don't need. Let's take a look at an example again. We have our weather loader here. This weather loader receives a weather service, nicely, and a logger, and it has a single method, getWeatherForLocation. However, our base class weather service does not only provide the getWeatherForLocation method, but it provides two methods, getWeather and getForecast. There's nothing really bad about that at the first glance. However, if you take a junior developer and ask him, please implement a weather loader for me, you give him that interface, then he has to do one thing. He has to look into the weather service and see which of the methods he needs to use in order to retrieve the weather. And chances are, although the interface of the weather service is pretty small, that your junior developer chooses the wrong method. Or he thinks like, when I'm retrieving the weather, I can also retrieve the forecast, and I cache it, although the forecast might never be used in your application, and so on. If you think that the weather service in a real application will have maybe a way larger interface, then you also have the problem that your junior developer needs to dig through lots and lots of documentation, needs to click through lots and lots of methods in your IDE in order to find what he's searching for. And there is still the chance, if you have stuff which is more crucial, like fetching weather, for example, sending emails in here, that your junior developer will go to the class and say, nice, I can also send an email to our administrator. And later you are wondering, like, why the hell is the application so slow? So what the interface segregation principle says is, in that case, where you know that you only need partial functionality of some class, while the class implements a single concern for itself, you can split down sub-concerns of this class using interfaces. For example, in that case, we could invent an interface called Location Weather Provider, which only provides the weather and not the forecast. Give it only this single method, and then say, our weather service implements Location Weather Provider. Then we have stripped down the usage for the weather loader into one single interface, because it can now say, I'm depending on a Location Weather Provider, and nobody will ever have access to the additional methods. So this is one of the most important applications for interfaces to strip down concerns, to encapsulate sub-concerns of one concern of a class in order to restrict its usage. And that is what the interface segregation principle says. Avoid that people need to accept unneeded dependencies. As I said, that is of course a slightly artificial example here because 2 methods are not too much to receive. But like 15 methods is already quite much. If you provide a service class implementation for a larger service, then you might gain 15 maybe simple methods, but forcing somebody to dig through all 15 methods in order to find what he's actually looking for is not a good idea. So if you want to provide a library that is easy to use, you should strip down this with interfaces so people can see, okay, I need this interface and that is really small and really easy to use and straightforward for me to do. And that is what the interface segregation principle says. Design interfaces always from a usage point. I had that always on the previous slide. I cannot repeat it often enough. Just extracting interfaces because I can is not a good idea. And try to not let unnecessary functionality float into your classes, which are not desired. As I said earlier, the interface segregation principle, especially in the PHP world, is like not the most important ones. The other principles I consider way more important, but it's still important to know that. Okay, I think I'm perfectly in time. So, to sum it up, the solid principles give you a nice checklist you can apply to your class design, to your objects, to your everyday development in order to make your classes more flexible, in order to make your application more flexible, because it allows you to create modular applications where you can replace fine-grained parts by dependency injection. And by now I think everybody in the PHP world has accepted that dependency injection is a solution to many, many, many problems. Look at the Symfony dependency injection container, or service container how it's called. It does exactly that, plugging your application together from small fine-grained parts, and it allows you to easily replace parts of your functionality without hacking your code actively. The solid principles, if you follow them, allow you to really create nicely crafted code which is really easily testable and easily doable, and you don't have to fear after that you can if you pull out parts of your code, your full application crashes, because pulling out parts of your code and replacing it with a different feature is simply done by the mechanisms I showed you today. The motivational posters were actually not my own stuff. They are CC by SA by somebody else. So if you want to download them, please go to that URL. Of course, I will upload the slides. And now we have time for some questions. Please.
So the web application abstraction features where you read information and...
Oh, you got a mic. That is pretty good.
If you can go to the slide with the...
Which one? This one?
Where you parse the XML and where you get the location from the city.
One of the very first slides, yeah?
The final one. The final. Of where it's totally...
This one?
No. With the code by.
That was the final slide, actually.
No, with the code you have two lines of parse.
Oh, okay. So from the very beginning of your presentation,
beginning.
I can go back there, but that is quite some clicking. Woo, 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 woo. Dum, 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 dum. Ah, okay. Dum, 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 dum. Yeah,
and here.
This one.
You can here expect that the XML, or if it should return an object, where should you put the type hiding of the type hinting? I should change my first question. Where should you check that the XML is really XML? Where should you provide that functionality?
I'm not sure if I got the question right.
If it is better to provide extra code here to put it in an if statement to really check.
Okay, so what you propose is that you check that the return stuff here is really XML.
Or should you provide it in the parse weather function as an argument checking or something like that?
Oh, I would expect that the parser checks if it got valid input and that it raises an exception if the input is invalid. So if that is your question, that for me that would be a concern belonging to the parser. Because otherwise I cannot change the data format at all if I have a manual check here that the data format is valid for that given parser. But since I want to be able to replace the parser, like for changing XML formats or whatever, in future it's maybe JSON, then it should belong to the parser. It can be a nested implementation of the parser, but
yeah, if it should return an object.
Okay, if you transfer an object here in order to have an encapsulation, that sounds like a good idea, yeah, because a string can never be checked by a type hint. So if you want to have type hinting, if you want to go into the direction of more strict types, then transferring objects here is a better idea, right?
Yeah, where should you place the type hinting? In here in the if structure or in the parse weather function?
Oh, actually it should be in the parser method then to have the type ein for the XML object then.
Okay. Yeah, that's one question.
Well, we can also discuss that in further detail after with a coffee. I think that makes more sense maybe. Additional questions? I'm skipping forward, so I hope that is okay.
I have a question to the example with the mile and kilometer calculator.
I'm sorry, I didn't get it.
Can you understand me? I have a question to the calculator.
To the calculator, yeah.
Yeah. Is there a rule to defer when it's a precondition? Let's say when this example is more critical. Let's say when a number is going to be minus. This is really bad for the application. So at this time, I would say this is a useful precondition where I should throw an exception. But you told here, throw the exception is really bad, and yeah, when can I say yes, this is useful, and when this is not useful?
Okay, maybe you misunderstood me a little bit. I did not say that such checks are in general bad. It's only bad if you do that when nobody expects it. So if you look into the code of the base class, then nobody would expect that this method would ever raise an exception because it's not there. So the implementer of that method would also not have documented that there may be an exception thrown because he did not intend the method to throw an exception. Now we have an extended class of this distance converter. It's a derived one. And here we throw an exception now. And that is what nobody expects, so you shouldn't do it here. In general, of course, such value checkings are pretty okay, but they must already be defined in the base class. So if you change the base class documentation and announce to everybody, come on guys, our distance converter should actually from now on throw an exception if it retrieves a negative value, then everything is fine. But you need to change it in the base class then. You need to make a bug fix though.
Okay, yeah, I missed this part.
Yeah.
Okay, thanks.
That is the essential point. More questions? Yeah, please.
I have a question about the Liskov. You said that the return values can be higher than the base class return values. My question is, what if someone's depend on the values that returns the base class, even if it's let's say less than 0 in this case, but it's incorrect, right? But what if someone depends on it somewhere else? Is it? I think it is a broken of this principle.
So the question is, what happens if you tighten the return type, basically? So how I explained it here, if you do that, basically, right? So if you only return floats which are greater than 0. of course, somebody can expect to react upon the case where a negative value comes back from here. But if you change that in your derived class, this if or however it's realized will never be executed. So there is no harm done to your application because it just reduces code that is executed and it does not lead to a clear error. Right? So if you put in something here and somebody the only case where this could really be a problem is if somebody throws in a negative value and expects a negative value to come out and explicitly expects that it's negative. So, but that could only be a test case, right? Otherwise, people will just assume, okay, I know how that method works. I assume there comes a float. And everybody needs to deal with that float. So there is no problem in there. So what you may do is you may always return less here, but you must never return more. It's never a good thing to return more here. Dum 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 dum. Jumping in the wrong direction. So this is absolutely forbidden. More questions? What does the time say actually? The time says 15 seconds left. Great. So I'm jumping to my presentation end again. Okay, before you leave the room, I want your attention for a topic which is really important for us as presenters at conferences and for the conference organizers, and that is to give feedback. To give us a hint if our presentations are good, if you liked it, if you learned something, if you say, oh, this Schlitt guy is an asshole, whatever. Please. Take your time, go to Joined In. Joined In is a nice tool where you can leave comments for individual presentations at this conference. You can give a rating, you can do that anonymously if you want to, but please do us all a favor and go to this URL and give some ratings. There are all talks of the SymfonyLive conference that you can give ratings to all of us, and we are in the lucky situation then that we can improve our talks for the next conferences and that we can see what people are interested in. So if you come back next year to SymfonyLive, then we will most probably have better talks if you rated them this year. Otherwise, if you want to stay in touch with me, don't hesitate to write me an email, to Twitter me, or to visit our website. And if you want to rent a quality expert, don't hesitate to ask me here at the conference also. Thanks for listening.